Hello pre-calculus students, I hope you're all doing well. We're going to begin today the introduction into section 11.3, which brings about some more identities, the sum and difference identities. And one of the things you'll see in the note packet that I send you for this section is this lovely identity remembrance sheet, like reference sheet. So we know the quotient rules. These are the new reciprocal identities, but you also know that it works the other way around. Tangent is 1 over cotangent, sine is 1 over cosecant, and cosine is 1 over secant. So there's more to it than just this. Pythagorean identities, we've talked about those. And again, there's 2 more to each of these. We've talked about that you could have. But here's the new ones. The sum identities, the difference identities. That's what's in this particular section. And you'll see that if you have the sine of 2 angles that are added together, you can separate it by taking the sine of the first number plus the sine of the second number, or times the sine of the second number, plus the cosine of the first and the sine of the second. So this one, sine functions, whether it be addition or subtraction, go sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And then you just fill in your 2 numbers. And this one, for sine, if it's plus here, it's plus here. If it's minus here, it's minus here. If I go to cosine of 2 angles and I'm trying to add them, their deal is cosine, cosine minus sine, sine. You'll see the sign is opposite. If this is a plus, this is a minus. Here's cosine of a minus b. You'll have cosine, cosine plus, because this is a minus, it becomes a plus, sine, sine. And for tangent, tangent's got a fraction involved. So tangent of 2 angles that I'm trying to add are tangent of the first plus tangent of the second over 1 minus, again, this is a plus, but on the bottom it's the opposite. Tangent of the first times tangent of the second. If it's a minus here, minus on top, plus on the bottom, and these are now the expanded forms of your identities for this particular section. We're going to talk about some of these other ones as the weeks go on, but for now we're just really concerned about these 2 boxes. So, for our intro problems, here's what I want to look at. You'll see over here they gave you the same formulas and they put them in this box, but they kind of mushed it all together. And they're using alphas and betas instead of A's and B's. Sometimes you'll see them as X's and Y's. But this is the expanded form. Sine, cosine, plus if it's plus, minus if it's minus, sine times cosine. Sine, cosine, cosine, sine for this one. If I'm doing cosines, the signs change in the middle. So you might want to just kind of keep this other reference sheet right here that's a little easier to read handy so that we can expand these out, because that's really what we're going to do. All right, let me show you how it works. Number 1, write the expression as the sine, cosine, or tangent of an angle. So I have to see how it's listed. Cosine of 45, cosine of 60. Sine of plus, sine of 45, sine of 60. So this one goes cosine, cosine, sine, sine. Well, I know if I look back over here, cosine, cosine, sine, sine. It's got to be the cosine of 2 angles. And it's going to be the opposite of whatever the signs are. All right, so let's see. If it's a minus here, that's going to be a plus. If it's a minus, if it's a plus here, it's going to be a minus. So what do we have? In the middle, we have a plus. That means it's going to be the cosine of the 2 angles, 45 and 60, but with the opposite sign in the middle. Because they gave you the expanded form and you're trying to figure out what the condensed form would be. Well, that just means that this would be equivalent to the cosine of a negative 15 degrees. And that's your answer. You can keep this in parentheses if you'd like. Without it, it's okay. All right, now here's the next thing they're going to have you do. And the whole point of this is what happens when you get numbers that are not on your unit circle, not on the chart. And by the way, the other chart that's going to be really handy to you that I'll keep in the notes as well is this guy. Remember this guy with this whole big table at the bottom? This table is going to be huge to us as we do this section. So if you have your table, I think we might have put it onto cardstock at some point in time, but if not, I did include a copy of it with the note packet that goes with the section. All right, so here's the story. I have the sine of 195 degrees. Well, 195 degrees is not on my chart. So I have to figure out a way, and I can use a sum or I can use a difference to be able to get to 195. So here's what I'm talking about. I can choose any two numbers that add or subtract to 195. So what I'm going to do is I'm going to choose, this is the sign, I can't change the trig function, it's still the sign. But if I want 195, well geez, I can get there by taking 150 degrees and adding it with 45 degrees. That gives me 195 degrees. Now you have other options you could have chosen that would have been equally correct and would still give you the same exact answer. I can get 195 degrees by taking 60 degrees and adding it with 135 degrees. And the whole idea is you want numbers that are on your chart. All right, so 60's on there, 135's on there, 50's on there, 150's on there, and 45's on there. I could also do a subtraction one. What if I took 225 and I subtracted away 30? That would give me 195 as well. So it's not right or wrong which combination you choose. You can pick any combination you want. You just want one that adds or subtracts to 195. Then what you're going to do is you're going to expand it using your rules. So if we go back to this lovely sheet, I have 150 as my A, 45 as my B, and I'm going to plug it into these places. So it's going to look like this if I expand this. It's going to be the sine of 150 cosine of 45 plus cosine of 150 and the sine of 45. And then I'm going to go to my table, this lovely guy here, and I'm going to look at 150, and I want to know what the sine is. The sine of 150 is 1/2. So I'm going to put a 1/2 in for this piece. That's this piece. Cosine of 45 is the next thing I have. 45 cosine is the square root of 2 over 2. That goes in for this one. Then I have a plus sign. Then I have the cosine of 150, come down to 150, go over to cosine. I get negative square root of 3 over 2. And the sine of 45, if I go back here, sine of 45, sorry for all the flipping back and forth, I get the square root of 2 over 2. I just want you to see where these numbers are coming from. And then I do the math, then I do the algebra. I'm multiplying, please excuse my dear Aunt Sally, so I'm multiplying before I add them up. 1 times the square root of 2 on top is the square root of 2. 2 times 2 is 4. Negative square root of 3 times a positive square root of 2 is a negative square root of 6. Because they're both inside the root, I can multiply them together. 2 times 2 is 4. Then I put the fraction together. See how nice it is? They have common denominators, and they should as you do the work. You end up with the square root of 2 minus, plus a negative, the square root of 6 all over 4, and that's my final answer. So you have just applied the sum identity for that particular function there. Then I get to the tangent of 105, the next one. Tangent of 105, I need to come up with a combination that's going to give me 105. I have lots of choices. It's your choice. You can pick any number. See my green guys here? I could have made it this and I'd get the same answer. So for 105, I'm going to pick the tangent of 60. Don't need parentheses yet. Tangent of 60 plus 45. Right, they're going to be my two to get 105. Again, you can pick a different combination. You're just still going to get the same answer in the end. So let's expand it considering this. So I'm going back to my chart and I see if I have a tangent of an A plus a B, it's going to be a fraction where it's the tangent of A, 60, plus the tangent of B, which is 45, over 1 minus these two things multiplied together. So tangent of 60, tangent of 45. So you expand it using your rule, using the identity. And then I'm going to replace it using the chart. So if I go to tangent of 60, on my chart I get a square root of 3. Tangent of 45 is 1. On the bottom I get 1 minus. This is the square root of 3. And this is 1. And so I clean it up, put it together, and I get the square root of 3 plus 1 all over 1 minus the square root of 3 times 1 is just a square root of 3. And so that's your answer. Now, The video is going to take you and rationalize this. Yes, you've got a square root in the denominator. Yes, the math police can come and take you away for that. But we're going to just leave it in that format there. That's fine. So you will see it rationalized. It all makes sense. But answers for us and things that you're going to turn in on tests or quizzes or whatever there might be, this is a perfectly valid answer right there. So the other thing I want to show you that comes up in the video, and let me change my color here, is something that looks like this. You'll get an answer. You'll do all this work, and you'll get something that looks like this. The square root of 3 over 3 plus 1 over 1 minus the square root of 3 over 3. So what if instead of square root, just the square root piece, I got these crazy fractions? That you do want to take one more step, and it's really simple. All you need to do is, see how you've got a denominator of 3? If you multiply by 3, everybody gets multiplied by 3. Watch and see what happens. The square root of 3 over 3 times 3 cancels the denominator. You get the square root of 3. 3 times 1 is 3. On the bottom, 1 times 3 is 3. This is minus. The square root of 3 over 3 times another 3, they are going to cancel the denominator out, and I get a square root of 3. And so here would be your answer, and that's perfectly valid. Again, it could be rationalized, probably should be rationalized by most math teachers, but for where we're at right now, this is great. All right, here comes the last couple. These now have the cosine of x plus y. I've got a function that they're giving me. I need to expand it, and then I'm going to evaluate it based off of these two criteria. Well, let's figure out the criteria first and what these things look like. What are they talking about here? So here's the story. You've got two triangles that are going to come up. These are reference triangles that we've learned about in other sections. So the reference triangle for this, I have an x triangle and I have a y triangle. And what I'm going to do is create them based off of the quadrant they tell me that I'm in. So for the first one, if I'm between 3 pi over 2 and 2 pi, I am in quadrant 4. Right? If I go around 0 to pi over 2 is the first, pi over 2 to pi is the second, pi to 3 pi over 2 is the third, and 3 pi over 2 to 2 pi closes it up and is quadrant 4. So we've talked about that before. So I'm going to create my x triangle first. I know my x triangle is in quadrant 4. It comes from the origin, goes to the x-axis in the fourth quadrant. And they tell me my cosine is 3/5. Well, if you remember, if this is my x angle coming from the origin, that the cosine is the adjacent over the hypotenuse. So my adjacent side is going to be 3. My hypotenuse is 5. Well, I need to figure out this missing side, and I can tell you for these particular sets of problems in this section, these always come out to be whole numbers. They don't come out to be square roots. So if you get a square root, you know you've done something wrong. So you're going to set up Pythagorean theorem based off of this. 3 squared plus some y value squared equals 5 squared. So 25, this is 9. If I subtract 25 minus 9, I get 16. The square root of 16 is 4. You probably knew that anyway because it's a 3, 4, 5 triangle, right? All right, so there's 4. But what kind of 4 would this be? If it's under the x-axis, this would have to be a negative 4. All right, that's your x values, your x angle, coming from information number 1. Information number 2 says the tangent is 5/12 in the third quadrant. So to get my y triangle, I'm in the third quadrant. Here I am, third quadrant. Here's y. It says tangent is 5/12. Well, if I'm here, tangent is opposite over adjacent. Opposite would be 5. Adjacent would be 12. Think about their positive and negativity. So I have a negative y value below the x-axis. I have a negative x value. I'm left of the y-axis. I'm below the x-axis and left of the y-axis. All right, then I need to figure out the missing side, the hypotenuse. So negative 5 squared plus negative 12 squared equals some hypotenuse squared. 25 and 144 is 169. Square root of 169 is 13. You can check that on the calc. All right, so job 1 is figure out your triangles based off your information. Now let's go back to the real problem. The problem said, all right, what's the cosine of x plus y? So if I take this, I got to expand that using our identity. Cosine rule says it's cosine of the first, cosine of the second, cosine, cosine, opposite middle, minus, sine, sine. And then I need to go to the triangles I've created. I've created the x triangle, the y triangle, and all I'm going to do is figure out these values. So if I'm cosine of x, I'm over here. X is, cosine is adjacent over hypotenuse. This is a value of 3/5. If I go to the y triangle, cosine in the y triangle is adjacent over hypotenuse, negative 12/13. 12, not 13. Negative 12/13. Subtraction sign. Sine of x, I'm back over here. Sine is the opposite over the hypotenuse, so this is going to be a negative 4/5. And the sine of y, go to the y triangle. Check out the y triangle. Opposite over hypotenuse is negative 5/13. All right. Please excuse your dear Aunt Sally. You're going to multiply first before you subtract. Negative 12 times 3 is a negative 36. 5 times 13 is 65. Come over here, watch this. Negative times negative is a positive, but which means it's going to stay a negative in the middle of subtraction. Negative 4 times negative 5 is 20. 5 times 13 is still 65. And when I put them together, I get a negative 56 over 65, and that, my friends, is your final answer. All right, well, more like that, because these are a little bit more beefy. This time they give me an alpha and a beta, and it doesn't matter. It can be x and y, it can be alpha, beta, it can be a and b, whatever. You've got two angles you're trying to subtract in this case. You have two triangles involved, an alpha triangle and a beta triangle. So we're going to figure out, oh, they told us quadrants. We don't even have to figure it out this time. So if I am the alpha, and I am in quadrant 1, alpha in quadrant 1 looks like that. Sine is opposite over hypotenuse. I need to figure out the missing x side in that, so that would be 5 squared equals 4 squared plus x squared. 25 minus 16 is 9, square root of 9 is 3. 3, 4, 5 triangle. It's a positive 3. If I go to my beta triangle, this one's in quadrant 3. It is the cosine. Cosine is adjacent, 24. Over hypotenuse, 25, and yes, it's a negative because I went to the left of the y-axis. I need to figure out what the y value would be. So I have 25 squared, the hypotenuse, equals negative 24 squared plus some y value squared. And so this one, if I go to my calculator and take and square these and subtract whatever, my y comes out to be a positive, actually comes out to be 7. When I put it on my triangle, though, it's really a negative 7 because it's a y value that's below the x-axis. All right, all your information is there. Now you go back and expand. Sine of alpha minus beta. That's going to be a sine of alpha, cosine of beta. Keep the same sign in the middle, so it's minus. Sine, cosine of alpha, sine of beta. All right, fill it in. Go to the alpha triangle, figure out the sine. Sine is opposite over hypotenuse, so this guy's a 4/5. Cosine of beta, go to the beta triangle. Cosine is adjacent over hypotenuse, negative 24/5. Minus cosine of alpha, go back to the alpha guy. Your cosine is adjacent over hypotenuse, so 3/5. And the sine of beta, go to your beta triangle. Sine is opposite over hypotenuse, negative 7/25. All right, multiply it out. 4 times negative 24 is a negative 96. 5 times, oh, this should have been a 25. 5 times 25 is 125. I have a negative makes this going to be a plus. And I've got 7 times 3 is 21. 5 times 125 is still 125. And when I take and subtract them this time, I get negative 75 over 125. And that actually reduces to be a negative 3/5. And so that's your answer for this one. So those are a little bit more work to get to the end, but they're really not that hard. You just got to create those triangles from back in the day of reference triangles. All right, one more thing that I want to show you before I call it a day with this introduction, and that is a problem that looks like this. The one other thing that comes up in this section that they're going to ask you to do is to do a verifying thing. So let me give you an example of that as well. So if I have a sine of x plus pi over 2, and supposedly I want to verify, or the question is, does it really equal the cosine of x? So this is kind of like those questions that we did back in 11.1. with the day 1, day 2, day 3 things that we did with the identities and using the identities. So I have to see, does this really equal, when I add these two up, does it really equal cosine of x? So what you're going to do is expand this using your identity rules for this section. It's the sine of the sum of two angles. So that would be sine of x, sine cosine of pi over 2, same sign in the middle, so plus, cosine of x sine of pi over 2. The question is, does it really equal the cosine of x? Sometimes they do and sometimes they don't in this particular section. So be careful of that. I know in the previous sections when they asked you to verify, it was like, yep, this is it. This one actually, I think it asks you, does the identity apply or something like that. The wording's a little bit different, but the process is the same. All right, so I'm thinking pi over 2, sine of x, I have no idea. I don't have any reference triangles. I don't have anything else I can say. It's just a sine of x. But cosine of pi over 2, I actually can identify what that is. If I do my unit circle, I go to pi over 2. You can go to your chart too. I have the coordinate, and the coordinate is 0, 1. Cosine is the x, sine is the y. So cosine of pi over 2 is 0. Then I have a plus sign. Cosine of x, I don't know what x is, so it's just a cosine of x. Sine of pi over 2 is the y value, that's a 1. The question is, does it really equal the cosine of x? Let's see. This is going to be 0. Sine times 0 is 0. This is going to be cosine times 1. That's cosine. So, yep, cosine of x actually does equal the cosine of x. So this one is a verified one, and the identity does apply. All right, so I will talk to you again with some more examples of practice problems from this section, but that's your introduction. I hope you're all doing well. I miss you, and I will talk to you soon. Bye.